Well, I've fixed the little issues, or some of the little issues. The first one being that I cut 3 spots on here rather than 4, so I did the other side obviously. Took it all apart. It's glued together, so all I had to do was just dunk it in some acetone overnight. I've marked the spots with a bit of black paint marker, and I made a little piece of spacer here so that we don't interfere with the carriage. And you'll notice that it all rotates nicely. Now, putting it together is an interesting exercise. I mean, it's relatively easy to make. This outer dial basically has to be solid with the top cover piece. It doesn't need to be clocked when it's put together. But the second dial, when you put it together, you also have to have the driving gear engaged. It needs to kind of be put together so that you can clock both dials at the same point. Then once that's in place, we can put the whole thing together and put the driving gear on the bottom, and you can use the driving gear with the carriage engaged, and basically engaged and run back against the lead screw to take up the slack, and then we set things up so that they are absolutely in line, and then tighten the driving gear in order to clock the whole thing. Now, we're currently set up for 2mm of thread, but here's what happens when we turn on. We're not engaged, so and you'll notice that the dial goes round, dial go round, dial go round, dial go round, dial go round. And here we've got through 1 turn of the interior dial and just got 1 turn of the exterior dial. And you'll notice that they go out of sync because they are not rotating at the same speed. And here again we've got the two sections there, and we're out of sync. So that's what happens when we go, and then if we engage, the dial stays still. As we thread, we disengage, come back, and the whole thing moves back to where it should be. So what I'm going to do, we're currently set up for 2 threads, 2mm per thread. So I'm going to do a scratch cut on here and then show that we can engage again. 2mm per thread is the 5 circle here that we'll be engaging. So I'll be engaging on the 5s. So let's get set up so you can see what's going on. Right, I'm now set up for a 2.25mm thread, which should engage on 7s. So, look, just lock the camera, there you go, and 7. Seven. Actually, hang on, that was the same 7. Disengage on a second one, shall we? Not that one. Not that one. That one there. And there we go. We are following perfectly. Woohoo! This is all good. Some more ink on. Then we get ourselves set up for something else. And this is the Shaolin Classic. What? Kick over the camera. That's the Shaolin Classic. No, okay. This is the Shaolin Classic. 1.6666. It's the thread. It's the buttress thread on Shaolin W20 collets, and this should engage every 4. Yeah. Maybe I should engage the lead screw. So I'm going to engage on this 4 here. And let's go back in, and we'll engage on that one, and there we go. We are putting 1.66666. Now, you'll notice that I've not been actually checking the threads against the thread gauge. That's because I trust my maths on working out what the threads are. But let's have a look. Oh, I don't have a thread gauge for this one, but I do have some collets, and that is bang on. You can't see. Let us just focus. Let's take it out of manual focus, push it into autofocus. There we are, manual focus. You will see that if we line those up, they are bang on. Absolutely bish bosh perfect. This means that I can make fake collets. I can make step collets and stuff, which is cool. Anyway, that's some testing of the thread dial. I mean, it's not the final version, but it proves that the principle works. The principle works properly. I will put out a set of plans, although the maths behind it is really easy. And I will put up a spreadsheet of the engagement points for the various threads, for a 3mm or for a 6mm lead screw, depending on what you have. But if you fancy making one of these, have at it. They're really quite neat.